Well, this is an accidental part 2. I meant to hit pause and accidentally stopped and can't undo that. So I'm going to have to pick up from where I left off. What did we figure out? We figured out that x equals 1.2 times 10 to the negative 5 molar. And what does that relate to? So this is the concentration of my hydroxide and of my conjugate, or my weak acid. What was I actually asked for? And then I can look up here. Let's see what questions we have. I said, do you need to include OH of pure water? Well, let's see. The OH concentration we came up with is the 1.2 times 10 to the negative 5. And with the 2 sig figs, that is going to be larger than the 10 to the negative 7. So the answer to this question is no, I do not need to include it. Can we ignore the K, or the minus X and the KB? Yes, we can, and we did. So we've answered those two, but we want what is the pH of the solution. So now I come down here and I'm like, but this is the concentration of hydroxide. There is no, what did I just write? There is no H3O plus in this reaction. I want to write it in the worst way. There we go. I'll just make it happen. Well, what can we do? We can figure out that the pOH is the negative log of my OH concentration. And then I can remind myself, let's see, we're at 25 degrees C. So at 25 degrees C, what do we know? We know that the sum of my pH and my pOH is 14. Where does this come from? It comes from the fact that at 25 degrees C, we know that neutral is 7. So therefore, the sum of these two is 14. And so if I figure out what my pOH is, I can just go straight to this, where I have 14 minus my pOH will give me my pH. Cool. So let's put this in here. I have pOH is negative log of 1.2 times 10 to the negative 5. And so I'm going to guess this to be, let's see, 10 to the negative 5 would give me a pOH of 5. I have slightly more than 1, so I'm thinking that my pOH is going to be slightly lower than that. Remember, this is the reverse world. So while something basic is going to have a higher pH, that means it's going to have a lower pOH, because we're doing pOH instead. So we can put that in our calculators, and what do we get? I get that I have a pOH as 4.92. Yep, 4.9208. Now let's talk sig figs. This has 2 sig figs. My concentration does. This is the equivalent of raising something. So what we're looking at is if X has 2 sig figs, then that means I'm going to have 2 sig figs after the decimal. That's going to carry out here. So this actually is now 3 sig figs. It kind of weirdly makes it look like more, but go back to that example that I gave you in last week's lecture notes to help remember why that is. So now, let's see, we have pH equals, now this 14, I truncated it, but it's actually 14.00, just keeping true to our sig figs, minus 4.92. And the little thing that I did right here, that sucks a lot of people in, because you write something down with too few sig figs and you let that thing tell you how many sig figs you have, and then you have a sad life because things don't come out as expected. So let's see. My pH then, I would expect to be greater than 7, right? Because I have a basic solution, and indeed I get 9.0792. So how many sig figs? I'm going to have 3 total. This has 3. I'm sorry, we're not doing a multiplication division. So it's going to be 2 after the decimal. So the fewest number of decimal in addition and subtraction gives you your sig figs. So we have answered the final piece to this. There you go.